Good afternoon to all of you, Putala. Today, can you hear me? Can you hear me?
Yes,
Yes.
sir.
Okay, very good. So today, 15th February 2021, 2018 B1 Manufacturing Food Process and IM batches, semester 6. So today, welcome for today class. So today we are going to discuss these things. This is related to cleaner production. What is PM in cleaner production? What is HEPA, IEQ, VOC, EPA, and CP? I just put this as the discussion for today. And 12 principles of green engineering and CP definition. Okay, and also there is one more newspaper article. We will see how far we can move forward. Yeah? We will see how far we can move forward. So PM, okay. PM means this is in environment, okay. PM means we call it particulate, okay, matter. So this is the name. So generally we call it's PM, particulate matter. So this refers very small particles. Very small particles, mostly suspended in air. Okay. So PM stands for particulate matter, also called particle pollutions. Generally, this is related to particle pollutions. Particles in the air, so particle pollutants, okay? Particle pollutants, not pollution, right? Pollutants. Yeah. So those pollutes the air. So this is related to air pollution. Yeah. So these particles can be even solid particles and liquid droplets found in the air. So these particles can be the bigger ones we can see, dust particles, dirt particles, soot means or even smoke. Those are larger enough. There are other small particles as well. Okay, those can be some bacteria, some virus, and even tiny, okay, very small other chemical and toxins also there can be as particles. So some can be solid particles, some can be liquid droplets. So this one is very important to have this knowledge about these small particles, okay. So if I add some particles, some photos, let's say, Okay. See, PM. Okay, particular matter. So you can see some, okay, the smokes. So there can be some other particles as well. Okay. See, these are possible. Okay. So when people are exposed to this, okay, people are exposed to this particulate matter, there is a health risk and also there are safety risks as well. Okay, health and safety, human health mainly. So this is prior knowledge because we know that environmental management and of course cleaner production both are important, because especially if we are damaging the environment and polluting the environment, okay, so those are issues. That's why so we have to have very basic knowledge about this environmental pollutions as well. So these are related to air pollutions, okay, these are related to air pollution. So when it comes to PM, there are two categories. Later you can explore more. One we call PM10, other we call PM 2.5. So those are the industrial standards of categorizing particulate matter, PM10 and PM 2.5. Okay, this knowledge is very important. Okay. So next slide, this is about what PM10 and what PM 2.5. PM 2.5 are much smaller than PM10. So 10 stands for this particle diameter. 2.5 stands for this particle diameter. So 10 means we call 10 micron and smaller particle sizes. 2.5 means 2.5 and smaller particles. Okay, so 2.5 microns. Later we will see what this size. We will try to understand how to configure this size. Okay, how to configure this size. Later we will try to compare this. So you know that 1 micron means, okay, so 1 micron means you know, if you take 1 meter, when you divide it by 1000, this is 1 milli. So 1 millimeter, when you divide it by 1000, So this is 1,000th of a millimeter. You imagine in your scale, you have the ruler maybe. Think of 1 millimeter, divide it into 1,000 pieces. Okay, you imagine how small these particles are. Okay, so 10 micron means 10 of, okay, 10 times this much. Okay, 10 times this. 10 times this. 10 of 1 microns. Still very small. Okay, still very small. So 2.5 micron size means, anyway, environment is not maths, but good to have this understanding. 2.5 micron means 2.5 times 1 micron. This is 1 micron. So 1,000th of a millimeter, 2.5 times of that is 1 micron. So it is quite clear. 10 microns is equal to 4 times 2.5 microns. Okay, so because 4 times 2.5 is 10. Okay, so later we will see some more on this. So this is about the sizes. So particulate matter, or the small particles, you are talking in micron size. Okay, micron size. So PM10, it is inhalable, can go into your respiratory system. So generally PM10 means inhalable. Okay, with diameters that are generally 10 micron. Then what's the difference? PM10 and why we have two standards? Mainly PM 2.5 can be diffused into bloodstreams once goes into lungs. That's why this PM 2.5 appears other than PM10. So PM10 inhalable, but not all inhalable goes to the bloodstreams, but PM 2.5 can goes into bloodstream. Okay, so can go into bloodstreams. So PM 2.5 is more unhealthier. So not to say more unhealthier, this is deadly. Okay, this is deadly. And do you know that every day we are inhaling with fresh air, even we are inhaling this PM 2.5 sizes. Okay, and PM10 inhalable means goes into the lungs. So this is unhealthy too. lot of respiratory problems can happen. Okay. Then we will try to imagine the sizes much more. Okay, again, in detail. Okay. The question, how small is 2.5 micrometers? Okay. So our hair, think about a single hair from your head. So that's how we should compare. Think about a single hair. The average human hair is about 70 micrometers, means 70 microns. Okay. Microns means micrometers. Okay. Microns means micrometers. So 70 microns here. So 2.5 is 30 times smaller. Other way, 30 of 2.5 micron diameter size equivalent to the diameter of hair. Okay. Yes. So the average human hair is 70 micron in diameter, making it 30 times bigger or larger than the largest fine particle, that is 2.5. Okay, largest fine is 2.5. Okay, so these are the fine particles. Okay, so 1/30th times fraction of, okay, fraction. So if you divide your hair diameter into 30, one piece equivalent to 2.5 micron diameter. So it's not a surprise that such sizes can go into lights. So it is not a surprise. That such fine particles of PM2.5 can go into light. Okay, so once go into blood, what happens? In the body, blood is the working fluid. So blood circulates, passes through all the organs. And then these particles from blood passing to the organs. Yes, and can stay there. In your hearts, lungs, kidneys, brains, all the vital organs. Yes, there is a high risk of getting this toxic particles. Okay, to explain this, we no need big science. We no need to be biologists. Okay, we no need to be microbiologists, or we no need to be biochemists. We can simply understand as being technology students. If you can realize this particle size, how small it is, no doubt, this goes in. Okay, so that is the issue. Okay, that's the issue. Next, The same thing. Here I'm circling. This is PM10 equivalent to 4 of PM2.5C because 2.5 times 4 is 10. So this one, PM10 of 7, here 5. So PM10s of several, maybe 7. 5 equivalent to 50 to 70. So 5 means 50 microns diameter of the hair. So you know the even tiny means we use the word hair. Sometimes hairy cracks. Okay, so tiny means so here let's say 1/5 to 1/7 or to 1/10 of this is PM10, let's say. So you can imagine these particles easily inhaled and then 2.5 goes to bloodstream through the lungs. Okay, so that's the issue. That's the issue. So 90 micron fine beach sand, it's here, you can see. It's of course bigger than fine beach sands. Very tiny, very fine. Still bigger than here. Okay. So you imagine when this goes in, we all are facing health issues. This is not a new photo because later I will show you this article. This is from a 2017 article, so this is well before Corona time. So for us, wearing a mask is new, but for some cities, those who are concerned about their health, wearing a mask became a norm. Okay, it becomes a standard because of the risk of this PM10 and PM2.5. Okay, PM10 and PM2.5. So there is a risk. Okay. Now I'm going to share with you one article. Later I will email this to you. Okay. This is about air pollution. You can read about this. So this is written by WHO Regional Director for South Asia. This was published in 2017. Okay. So I take only this part. Just 2.5 lines. I'm going to copy this. So you know reference there, the source of this. So this is not I say. Okay, this is not I say. This is about health risk of air pollution. Yes. Cancer, strokes, heart diseases, lung diseases, asthma. These are some of the life-threatening diseases caused by air pollution. A problem that kills more than 6 million people worldwide every year, and which is the most pressing environmental health risk humanity faces. This is true. You may think that cancer causes by maybe poor quality water or maybe the food you are taking, but you and me, we are mistaken. The main cause of these diseases are exposing us to air pollution. Okay, so that is the main cause. This may be the first time you are noticing this. Caused by air pollution. This is a surprise, but this is true. Okay, this is a surprise, but this is a fact. Okay, so understanding about this health risk and about this PM 10 and 2.5 is important. Okay, and the sources of PM fine particles. So PM 2.5, let's say. Yes. PM 10 and PM 2.5. So these chemicals can be made up of hundreds of different chemicals because industries are using a lot of chemicals, and even in automobiles, vehicles, inside the engine, chemical reactions are taking place. So most of the pollutants are chemicals. So some maybe fine dusts and all, maybe construction sites. So unfinished or unpaved roads may mainly the dust, sources of the dust. And fields means, example, minefields, even agricultural fields. Okay, and there can be other sites as well. Okay, and smokestacks or fire even. So this can be the sources, but other than that, even in the atmosphere, there can be this photochemical reactions and particles are formed in the atmosphere because of the emissions of sulfur dioxide and nitrogen oxides, we call SOx and NOx. So these are the pollutants emitting from power plants, even like Norocholio, whatever power plants, vehicles, industries, and more. So we are living with this health risks all the while. That's why you can see In the city areas, industrial areas, power plant localities, mine sites, okay, closer to mine sites, localities, nearby, which means nearby, okay, nearby. The people are living. The people are living. Are not facing, are really experiencing health risks, health issues due to air pollutions. This is a fact. This is a fact. So, but in villages, air pollution may be just because of a fire. That's all maybe. Yeah. So you can see nowadays the corona situation. So actually, death from corona is around, let's say, 3 to 7, 8, but saving of life because people are not coming to the cities and wearing masks. So people's lives are better and safe. Nowadays, health risks become minimal because people used to wear masks. People are coming to cities only for the requirements. Okay. So nowadays, because of the corona situation, many are keeping safe. So you can see this. You can see this. Even city areas, because of lower traffic, lesser traffic, the environmental pollutions become quite minimal. I think below 30% of the before corona period or before corona times. So those are good things. Overall, when it comes to environment, corona helps. Anyway, this happened to be the situation. Okay. Also, in some industries, so you are talking only about this outdoor. Okay. You are talking about outdoor, outside your homes. So in the streets, cities, industrial estates, you are talking about this. But indoors, also air quality can be a concern. Okay. Ah, okay. Thank you. Okay. So same way, indoor also air quality can be a concern. So indoor air quality, this one we call the famous IEQ. Okay, so we just talk about the PM only. Not that we are going into deeper levels, but We are going into have just awareness of this. So later you can look into what kind of particulate matters generally we are experiencing, we are getting exposed. Okay. So indoor air quality. Example, let's say inside the factories. Okay. Inside the factories, actually, some factories, like let's say not to say some, but many factories, like I think you have some experiences because you underwent industrial training and exposure. IAQ, okay, IAQ is at alarming levels. You feel it because your body one phase sense this. IAQ at alarming levels. Example, metal industries. You feel this. Dusts, emissions, all. Because by right it should be cleaner and safe for human, but you can see metal industries. Also, metal finishing industries. Metal finishing means painting, powder coating, okay, powder coating, galvanizing, etc. Powder. Printing industries. When you take the newspaper, you feel a good smell, but it is really not good for health. Printing industries. Yes. Even cement. Cement. So construction material. So then other heavy engineering. And even construction. So you can say, and even garment industry. I think garment industry also there are a lot of powder-like formation, maybe fine particles of fabrics. Okay. Yes. Not to say there can be a lot of chemical industries. Those who are working inside. Really are facing health risks. In that way, you can see farming, agriculture may be better because less health risk unless you are using chemicals. That's why they also you are using chemicals. So you are exposed to that. But those are outdoor maybe, but indoor, we really are facing health risks. So you imagine your parents, your elder brothers and sisters. So those who are going to cities and towns and to work in the factories and all, okay, garment factories, okay, refineries, everything. See, they may not be telling those stories to you, okay, but for you, for your better life and future, they are even sacrificing their health. They are not telling it to you, okay. So that's why you should have a very great gratitude for your parents, those who are exposed into this. So having only gratitude is not enough. So you should learn about this, and for the future generations, including you, dealing with this air pollutions, not only air pollutions, and including air pollutions, taking care of the environment is one of your prime responsibilities. Okay, that's why you cannot limit these to subjects. Okay, so you should aware this. So creating a cleaner environment, greener environment is a responsibility with us. Okay. And we can see that many those industries, maybe those who own these industries, they may not be taking care. Give me a second, Pata. Okay, Pata. So that's why. So having a knowledge of this should be useful for you. That is very important. So whenever you learn something, you should question what's the purpose of knowing this. Yeah. Good. So you have to look into this with technology. So all the solutions for this solutions and the answers for this answers for solutions and answers. Definitely technology play a big role, and IM students know that innovation is the answer. Okay, IM students know this. Yeah, so somehow we have to look into these things. So when you after graduation or before graduation, if you are going to work for industry or if you are starting some venture, so you have to explore this risks. Okay, explore this risks to make this minimized, because safe environment is a human right. And not only that, if you happen to be the boss, taking care or assuring the health of your staff is a noble responsibility of yours. Okay. So wherever, not only in the industries, wherever, if someone exposed to this risk, probably with no knowledge of this, educating them, okay, advising them is very useful. So my recommendation is, even after Corona, if the environment remains the same, wearing a mask is an investment for your health. Okay, that's an investment. Not the insurance, but the mask can be the investment. Okay, Bhutala. So if you think about masks, yes, one side we have PM 2.5, all the chemicals, N95, okay, N95, either is okay, NOKN or whatever, because N is Chinese standard and KN is US standard. Okay, so KNO N95 is the mask rating. So I thought of sharing this as well. PM 2.5 is the particulate matter ratings. So N95 masks can help, okay, to prevent exposing to PM 2.5 to reasonable sizes, okay, to reasonable levels. Okay, so mask and this particulate size goes together, mass ratings, because that is for filtration of particles. 10 microns. See the blood cell size. This is 2.5. See, smaller than a blood cell. So this can easily go into this. Simple. So bacteria, more smaller, coronavirus 0.1, but still this can be managed with N95. So which is same as the performance of surgical masks. You can explore those. Okay, you can explore those about the masks. Okay, masks means what the mask is doing. The purpose of mask. Mask is a filter. What filter? Air filter. Okay, it's an air filter mask. Okay, it's an air filter. So there can be different filter technologies, filtration. Okay, so you have to understand this as well. Okay, masks. So air filter. There are filtration techniques. Filtration techniques. You should explore. You should explore this. Because when you are going for industries, yeah, you have to explore the basic technologies. So what are the means of the strategies of filtering or blocking the micron particles? Imagine from your mask you can breathe, but if you think the filter, the airspace is smaller than PM 2.5 size to filter the particles, you cannot breathe. Means the air gaps in the filter to breathe there. If you think it should be smaller than PM 2.5 micron size, you cannot breathe. That's why. So filtration has its own techniques. Okay, with little pressure drops, means with ease of breathing. Okay, with ease of breathing, to filter it to the maximum levels, let's say over 95% efficient, even for corona virus filtration. So you imagine that kind of filter technologies. Okay, so these filters are made of fiber. We call those are HEPA filters. HEPA filter. There can be fabrics, fiber fabrics, maybe fiber. Okay, fiber material, different fiber material. Yeah, those are health friendly. I mean, safe for health fiber material. You can explore this. So HEPA means high efficiency particulate, yes, air filter. That is what. So particulate matter, this matter is, the M is dropped here. So HEPA, high efficiency particulate air filters. So in your N95, you have maybe in several layers for the better performance, whatever. So HEPA is one of the industrial standards. Okay, this is an industry standard. Industry standard. You can go through about this. So if I share with you something about HEPA filters, maybe later you can look into this. HEPA filter. Some images only. And let me share with you the screen. HEPA filters. You can see. Yes. So there are wonderful technologies. Effects of air pollutions. These are only very little. Okay. A lot of air pollution issues. So these are the phenomena of filtration here. You can see. So filters, having an interest of developing a filter, it is good really if you can know the phenomena behind this. Filtration principles. Okay, that is very important. Okay, as technology students. Even you can try to develop Oh, try for filter innovations. Okay, try for filter innovations. Yes, this in 95. Originally, it's an innovation done by a Taiwanese in 95. It's a Taiwan innovation or invention. I think it's an innovation because filters are there. It's a Taiwan innovation, if I'm not mistaken, because Taiwan, they have the semiconductor industries. Okay, so they are using a lot of nanotechnology application, and this PM 2.5 is a risk for the quality of their electronic productions. So they have to have much cleaner indoor air quality. Okay, so that's why. So initially for industrial applications and finally came to biomedical and health applications. Yes, you can study this. Okay, so those are very important. So today our lessons about this PM, HEPA, IAQ. Actually, we are not going for deeper studies because we are manufacturing, IM, and food bank. The basic awareness of this is good enough. Okay, and this VOC, VOC, VOC. Do you know VOC? I think you all know about the VOC. You see that VOC, VOC mark, VOC plates and all. Huh? VOC, not that. Okay. In environmental management, VOC is a famous word stand for volatile organic compounds. Okay. May I give you some examples? May I give you some examples? Yeah. Because you have already inhaled those. Yeah. And even at tiniest levels, those are inside your bodies. Yes. VOCs. The scent you are spraying, you feel very nice smell. Okay, scent. Of course, there can be natural scents. We call essential oils, not about that. Chemical scents. Okay, chemical scents. You feel a very nice smell means already those particles goes inside. Okay. Sometimes the furnitures, new furniture. You have a new furniture smell. You feel good to smell. Smell means these particles already sensed inside. So inhale. VOC. New paint smells. Smell means already inside your body. VOCs. your air freshness, okay, made of chemicals, okay, chemical air freshness. I think that should be all right. Air freshness, chemical ones. You feel the smell because volatile means volatile can wash facility. So at normal atmospheric conditions, these are evaporating once exposed. Okay, so these are volatile organic compounds. Sometimes when you open a new book, you feel the good fresh smell. VOC. Newspaper, the hot one, you feel a smell. What's that? VOC. Okay. Sometimes toys, not the plastic one, but the painted one and all. The newness smell. Don't give these toys to children. Okay. That contains VOC. Sometimes wall paints. Sometimes the quick drying paints, aerosols, yes, contains VOC. Even petrol, some they feel the good smell. VOC. Sometimes even carpeting the roads. When you go nearby, you can see very bad, very strong, unbearable smell. It's a huge dose of VOC. Yes. Then some chemicals, some coming out from exhaust. Okay, exhaust. Maybe vehicles or maybe other this stacks or the fire stacks or what. You can feel this. Okay. And even hot day, if you get into a car, you feel the smell. Hot noontime or daytime. Hot daytime. Getting into a car, you feel a smell because something evaporated, trapped there. VOC. Okay. The issue with VOC is directly goes to what? Blood. Then to liver. Okay. L-I or L-E-V-E-R? I don't. What liver? I don't know. Check the spelling. Yeah. Then to liver. Stays because VOC is not recognized by the body as toxins. It stays there, causing sicknesses. Okay. First, it makes the liver sick. Okay. That's why even in some developed countries, industrial areas, very easily you can smell this VOC. Yeah. So VOC smell means your health is at risk. Okay. So this is about VOC, volatile organic compounds. So later we will see what are the technologies industries are using to control VOC. Technologies. The industries are using to control VOC and PM. We are going to learn this. Not today. Okay. Not today. Okay. Give me 7 minutes, Buddha. Give me 7 minutes. I'm asking. Just cover now. So I need to share with you what is USEPA. Yes. Let me share with you the screen. Okay. I'll share the screen. USEPA is a very good website. Actually, this is United States Environmental Protection Agency. This is a very good website. It's a huge knowledge base. US, we may have issues, but this US EPA is wonderful. Okay, you can learn about everything because if you need the source, this is one of the best sources. If you need to know about VOC, type VOC. Yes. See VOCs, they are working a lot about this VOCs. See, ozone VOCs also. So what are volatile organic compounds? You learn about this. See, volatile organic compounds impact on IAQ. Read this. Paints, even paint removers, even your Q-Tex, sometimes the girls are using. Removing Q-Tex, the chemicals you are using, VOC. Paint strippers and other solvents, aerosols, even your dry cleaned shirts and dresses also contains VOC, that's bad. Acid dry clean clothing, yes. Pesticides, hobby supplies, stove fuels and automotive products, moth repellents and air fresheners, cleansers and disinfectants, aerosol sprays, wood preservatives, building material, furnishing, office equipment, graphic and craft materials. See, damage to liver, kidney, and central nervous system, health effect. Headaches, loss of coordination, maybe in long term. Yes. Key signs or symptoms associated with exposure to VOC. Yes, long-term exposure. Yes, even there is a potential for cancers as well. Okay, in the liver. Okay. VOC levels in the homes can be quite high. So this one, Putala, you have to read this. Reading material. Okay. You know why you should read this? Because it's your responsibility to know this. ඔය කට්ටිය දැනගන්නේ නැත්තම් මේක කවුද දැනගන්නේ? You should know this, and you should save the industries, the people they are working, by even taking tinier steps to help to improve the human health in the industries. Not only in the industries, even in indoor levels, indoor air quality. So it's your responsibility as a responsible citizen having this knowledge. It is mandatory. I would say it is mandatory. This is not for exams, of course, for exams, this will come. How to manage VOC in industries and all, but this is more than that. This is your social responsibility when you go to industry. Okay, that's why to carry out your responsibility, to go for appropriate innovations, new developments, new solutions, and all. So if you don't consider this environmental dimension, yes, then you are not doing the something complete. So this is your responsibility. So as being responsible, because since you are living on this earth, in this, very much in this country, on behalf of this country, the nation and the citizen, you should know this, not for a salary or a certificate, but wherever there is a chance to contribute, you should contribute. So if you have a good heart, do some good learning out of this. At least develop a filter. Try how to make it. You can make it. Okay. Yeah, you are the ones to explore the technologies, innovations, and more. So this knowledge brings you lot of opportunities to contribute, lot of opportunities to do innovations. Okay, lot of opportunities to save the environment. So this happened to be the day 2, maybe, or day 1, day 3, I cannot remember. Putame devani dawasada tumini dawasada is this? Can you tell me? Is this day 2 or day 3, Buddha? අපි දවස් කීයක් කෙරුවද මේ lecture එක? Classic. Yes, I'm receiving. Yes, this is the 3rd day. Okay, very good. That's why we are on technologies. Very good. So later we will have assignments or whatever, but please get some good knowledge on this. Let me text this link to you all. To all. Everyone. So how to text? How? So this goes to only one. Okay. Everyone. Okay. Yeah, I have this. Yeah. So this is the website. So this is about US EPA. So you learn about these things. When you have free time, you just read this. Even there are design guidelines. Yeah. Explore. The science technology is there for you to explore. So thank you, Putala. Today, nearly 60 students joined today's session. So it is really good. So I believe you got something. I believe you got something. And if you have a good heart and mind, yes, you have something to move forward. So don't consider this just limiting to the subject. Subject wise, quite relevant, no issues, but application wise, knowledge wise, to contribute, this has more values. So thank you, Bhutala. So let me upload this as well afterward. So that's all. Any questions before winding up the session? Just 1 minute. Any questions? Okay. Okay. So that's also, let me stop the class. So here we just, how to say, we just explore only, and you have to explore some more on this. So that is very important. So there are sciences, technologies. We may have limitations, but we will try our best to go for a wider scope and to a reasonable depth. Okay. Yeah. So still the preparations are ongoing, and today is about air pollutions and about PM. And the industrial issues related to air pollution, just an exposure only for today. So similar way, we have to learn about others as well. And we have to talk about other environmental aspects, about resource management, value chains, some strategic approaches, lot of things we have to study. So we will go step by step. Anyway, today happened to be the third day, should be very nice. Thank you, Bhutana. So let me stop the class. Bye then.
Thank you, sir.
Thank
Thank
you,
you,
sir.
sir.
Bye then.
Thank you, sir.